broadcast is on there live. This Hangout on there is live. And so this is Property-Based Testing Practice Volume 4 as I'm preparing for a talk on Thursday about property-based testing, okay? So I've recorded 3 videos of me trying to figure out an outline and then refining it, and that's pretty much it. And so this is yet another video of me just live streaming my preparation of giving that talk, or for giving that talk. And so far, I think I've established a minimal outline. And after, when I'm giving the talk, I'll do some live coding, and I'll probably have a cheat sheet tucked away in my back pocket if I have to pull it out. But that's about it. So I've reduced the number of bullets in my outline, and I removed the section about ecosystems. However, I kind of elaborated on, object-oriented programming, functional programming. So, all right, let me have a moment of silence. Okay, and then I start, and I pretty much open up with, what's object-oriented programming? And I asked that to the audience. What's object-oriented programming? And they respond, and I say, okay, what are some characteristics of object-oriented programming? And they respond. I don't really pay them any attention. Maybe I do. All right. And I pretty much say, well, here's some characteristics of object-oriented programming that you take note of if you are familiar with other paradigms of building software. With object-oriented programming, it tends to rely heavily on state, which in turn relies heavily on side effects. Like, object-oriented programming could probably be renamed to side effect-driven development, because what we do is we create these classes that not only have properties or states attached to these classes, but they also have behaviors as well. And what's interesting about idiomatic object-oriented programming is that when we execute these behaviors, which we call methods, these methods will execute a sequence of statements, one after another. And these statements, when they get executed, sooner or later are going to have a side effect, in which that side effect will be the mutation of a member variable on that class, or in this case, at runtime, an object, or a property on that class, or in this case, at runtime, an object. So to summarize, within object-oriented programming, this paradigm of building software tends to rely heavily on state, which in turn relies heavily on side effects, in which we have a set of statements that we bundle up and call it a method. And when we execute that method, we are actually relying on a side effect that results from the execution of statements that ultimately mutate state by means of member variables or properties. That's a characteristic of object-oriented programming. That is what we probably should call side effect-driven development, because essentially that's idiomatic object-oriented programming is essentially side effect-driven development, okay? Now, that's object-oriented programming. Who could tell me what functional programming is? Anybody? And then someone raises their hand. They tell me what functional programming is. And I say, okay. So what are some characteristics of functional programming? And they may tell me some characteristics of functional programming. And then I speak over them and I say, well, here's what I capture as the fundamental characteristics of functional programming. Functional programming relies on a minimal amount of side effects. Okay. Instead, it relies on immutability and functions to ultimately return state. So, unlike object-oriented programming that has no problem with modifying values, hence variables, with functional programming, we don't have variables. We have values that are immutable. And when we need to change that value, well, we can't. We have to create a copy of that value with some alterations. So those are the main characteristics of functional programming that I would like to highlight that is different from object-oriented programming. Object-oriented programming is what I call side effect driven development, whereas functional programming is development that deals with immutability and prefers functions or stateless. I don't want to say stateless driven development because at the end there's some state, but we basically rely on functions that are, well, by definition, deterministic to give us state, to return us state, but not modify state. Okay. So to summarize, unlike object-oriented programming, which relies heavily on state and it executes statements that are bundled into something that we call methods that ultimately perform side effects by means of mutating states or mutating member variables and properties. With functional programming, we don't really rely on side effects. And if we do, it's very minimal. But instead, we rely on immutability so that our data doesn't change from underneath us. And we instead of us relying on statements that are bundled together that we call methods to execute, no, we instead rely on functions. And every function is going to take an input and it's going to return an output. And we're able to basically compose functions or chain functions together, kind of like Legos, to give us what we want. And well, that's, for me, the fundamental difference between object-oriented programming and functional programming. So, yeah, I was supposed to ask you guys what's the difference between the two, but I just took the liberty of doing it for you. That's the difference that I recognize. So I think it's important to clarify the essence of object-oriented programming. I think it's important to clarify the essence of functional programming. And I think it was paramount to distinguish the differences between the two. With that said, we've laid down a foundation. Now let's start building on it, okay? What's a unit test? They tell me what a unit test is. And they say it's a test that, well, or it's code that essentially tests a unit of code, all right? Something to that effect. you're testing a unit of code. You're isolating it from everything else so that it could be tested in isolation, something to that effect. And I'll probably like Wikipedia the definition as I'm giving the talk, blah, blah, blah. And I'll say, okay. So what are some examples of a unit test? Anybody? Just at a high level. What's an example of a unit test? And someone may raise their hand, hopefully. They give me an example of a unit test that hopefully is accurate and we have a consensus or reach a consensus of, yeah, that's the essence of a unit test. And then I follow up with, well, let's take what you said and let's break this down, okay? What are we really testing based on your example? They say blah, blah, blah. Okay. In order to test that, do we not need inputs to test that? And they say blah, blah, blah. And I say, all right. So what are those inputs? And they say blah. All right. So the inputs are blah. Okay. And we are testing for an output to be what? They say blah, blah. And I say, all right, cool. So your inputs are blah, and your outputs are blah, blah, or output, singular, blah, blah, right? So then I say, okay. So this unit test that we're talking about, it's really an example-based test, right? Because we're specifying an example of what we want to test, but it doesn't cover everything, right? So if we were talking about addition, an example of obtaining a sum from two numbers would be 2 as an input, 3 as an input, and when you pass them into an add operation, the output is 5. But again, what are our inputs? For this specific test, example is 2 and 3. What is our output? What do we expect as our output? For this specific example of adding 2 and 3, our expected output is 5. Hence, 2 plus 3 is 5. Hence, this is an example of validating that a method that we wrote or a function that we wrote works. But it's just one example. Now, how many examples do you need to have a warm, fuzzy feeling about testing a block of code? Whether it's a behavior, a specific method, what number of examples, how many examples would you need for testing for you to say that this code works? And they probably don't say anything because it's kind of rhetorical. And so then I say, okay, well, note how I asked about how many examples would it take for you to have a warm, fuzzy feeling about a unit test. I'm sorry, an example-based test. Let me say that again. How many examples do you need? How many example-based tests would you need to have confidence that a piece of code works, that a piece of code is safe when it's executed, that a piece of code will always deliver value when executed, and it's the right value. Now, if you're thinking about the question that I asked, then surely you have to consider examples of edge cases. Now, when I say edge case, what does that mean? What's the definition of an edge case? Anybody? What's the definition of an edge case? Someone raises their hand and they provide the definition of an edge case and they say, blah, 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 and blah. And I say, all right, cool. So if that's the definition of an edge case, well, how do we identify edge cases? Like, what does that look like? Is there a process to identify edge cases? How do you say, I need an edge case for testing this code? Okay, what do you do to flesh that out? How do you identify an edge case for testing? And people say, well, blah, 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 and blah, 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 blah. And I say, okay. Well, based on your response of how to identify an edge case for testing code, and you said blah, 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 blah. Is there an alternative way to identify edge cases? Translated, is there a way to auto-generate edge cases? To auto-generate it. Not you brainstorm it as a human with a magnificent mind, which requires mental effort to think about these edge cases that don't happen frequently, like other examples that we use to test. Is there a way to auto-generate these cases using computing instead of us having to brainstorm it? What do you think? And I look at the crowd and they look back at me. Ladies and gentlemen, I introduce to you property-based testing. And people applaud. Now, property-based testing, a tool used to challenge your assumptions about a function. We're talking about functional programming here, y'all. We don't do methods anymore. That's like last generation. That's old school. Today, we don't do methods. We do functions. Deterministic, right? Always take an input, always returns an output. Deterministic, okay? In addition, it's a tool used to enhance how we reason about our code, okay? This phrase, reason about code, has been a popular phrase, over the past couple years. But if you are a professional developer, which I choose to say professional software engineer, I would like to say that better. If you are a software craftsman, if you are a SDET, software development, engineer, and test, then surely you scrutinize your code. Surely you reason about the code that you're looking at. Does this make sense? Does this reflect the logic that should really be executed based on the business requirements, based on the information that we have about this domain? Reason about this code. Well, property-based testing, again, it's a tool used to challenge your assumptions, but also it's a tool used to enhance the way that we reason about our code. You guys curious about how this works? and they roar and stand up and they start applauding. Encore. They start whistling. They start barking like dogs, dog pound, right? They're excited. I'm excited. And then I have to calm them down. So I wait, just like President Obama. I wait for everybody to stop clapping. I wait for them to settle down, take their seats again. And I take a deep breath, feeling myself, and then I continue. And I start live coding, right? And so I guess I need to share my screen now. And oh, holy crap, I have a viewer. Okay. I've been entertaining somebody. I thought I was just entertaining myself. So then I got to share my screen and I do a full screen and I say screen share and I present to everyone. And then I close out my outline and I guess I could close you too. And I guess I could close this window, and I guess I can close this paint thingy, and I guess I can close this file directory and that file directory and whatever error I was trying to troubleshoot on Stack Overflow. And I have a pretty picture of Cookie as I get ready to launch Visual Studio to do some live coding, right? So there should be where am I at? Property testing thingy. And that's going to load up. And I need to turn on the light because it's getting dark down here in Miami. Come here. All right. And so I have some code. And well, what I'm going to do is I'm going to delete all of this. And I'm going to revisit 2 minutes ago, and I said, who's ready for a demo? And everybody starts cheering and roaring and applauding, standing up, doing just like the dog pound, and I wait for them to simmer down. And then I say, all right, cool. So remember, I said that with property-based testing, you challenge your assumptions. Well, assumptions about what? You challenge your assumptions about a function, okay? And well, what does that really mean? Well, you look at a function, and remember in the past, I said when I said reason about your code, scrutinize your code. Well, we want to scrutinize a function. Specifically, we want to scrutinize the properties of a function, right? And so when we scrutinize the properties of a function, we want to, well, take an example, right? So an example would be to write a test saying, let's say that we want to do multiplication. We want to say that A, or let's say X times Y is always greater than X plus Y, okay? That's our assumption, okay? And so that's our assumption. I can go ahead and build this, and I didn't really fill out the test yet. I just wrote a function, but this function is not going to be discovered by Test Explorer because there's some things that we need to do. One is we need to open some libraries or some modules, should I say, that we pretty much imported by adding some NuGet packages. In this case, we need to open fscheck, and we need to open fscheck.xunit. All right. So after we do that, we need to apply an attribute called property, and we need to say quiet, I don't know how to spell quiet though. Quiet on success equals true, something like that. And that's all we need for right now. If I build this just like that, hopefully you'll notice that we have our test explorer updated. We have a test discovered, okay? Now, what do we want to do? Well, we want to fill in the guts of this x times y is always greater than x plus y test method, okay? Or shall I say property test. How do we do that? All right, well, we do that by every property-based test relies on a data generator. So we can say let generator equals, and we will have a arbitrary dot generate, and we want to generate within angle brackets an integer, okay? Now what? Well, we established our generator. What do we want to do? Well, the test is x times y is always greater than x plus y, okay? So we need to write code that tests that assumption, okay? Well, if you notice, we need to test we need to have two numbers, right? We need to have an x and we need to have a y, okay? So how do we do that? Well, how do you do that? I think we can say, how do we do that? I'm not sure. Let me see. We can do something like this. We can say generator, and we can do gen.map2, and we can pipe that into arb.from generator, okay? And then we can pipe that into prop.for all, not for pal, for all. And we can do a backwards pipe operator and provide a function that pipes into that saying fun. There's something that I'm missing, but I'm just going to keep on going. Yeah. Before I get there, that gen.map2 actually needs to take in up here a function that will take an x and a y, hence from our generator that generates an x, generator that generates a y, and we want to take that and we want to basically generate a tuple pair of x, y, like that, okay? And when we do that, we say arbitrary.from generator. We pipe that value from the from generator function to another function called prop.forall, and we should then have a tuple, which we'll call a b, and we will basically say that a times b is greater than a plus b, like that, okay? And we got some red squigglies here, okay? So what am I doing wrong here? If I look at this over here, map the given function. Oh, what's the error? It says type mismatch, expecting gen int. Well, it's expecting a function of gen int, gen but given a gen. Okay. So What do I need to do here? Well, I said gen map 2. Oh, shoot. Do something like that. And I don't have any squigglies on there. So I should be able to build successfully and to build successfully. All right. So what do we have? Well, this is, I wonder if I could just, well, no, okay. So what I did was I defined a generator. This generator is going to generate int values, right? Integer values. And well, I need two operands. I need x and y to use for both multiplication and as well as addition, right? So here I create two values by basically taking that generator and basically passing in that generator into a gen.map2 function, which is essentially the same as if I did, let me see, if I comment out this and if I remove this, then it's essentially this right here. Maybe it's not. La 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 la. Not sure how that goes. I'm kind of rusty on F# right now, but it should actually work like that because it's the last two. Anyway, I take these two generators, I pipe it into gen.map2, and that's going to provide a value for the first generator. It's going to provide a value for the second generator. And I take those values from generator 1 and generator 2, and I basically create a tuple from those values, hence x comma y. And then I do some ceremony, which I then say arbitrary from generator, right? And then I say prop.forAll, and that's going to take basically a list of values, and for each value within that list, by default, it's going to be 100, right? Based on this property attribute, the default is 100, which is implicit. It's not explicit on here. We take that tuple that we defined up here, that comes from a list of tuples that gets automatically generated, and we basically decompose that tuple, and we extract values from that tuple. Hence, we extract A, we extract B, and we're able to basically provide an expression asking, is A times B greater than B, or greater than A plus B? And so then we should be able to run this, hence me clicking run all. And what's going to happen is we should see that the test fails. And when we see that this test fails, we see that this property-based test provides us an example of why the test failed. It generated an edge case for us. All right. Remember when I was saying, well, is there a way that we can auto-generate edge cases? Well, we can. It's through property-based testing. And here is an example. We write a property test, and we assume that when you multiply two numbers, the result will always be greater than when you add two numbers. And it's saying that is not true. That is not true. Here's an example, 2 and 0. Well, 2 times 0 is 0. And then we ask, well, is 0 greater than 2 plus 0, which would be 2? Is 0 greater than 2? 0 is not greater than 2, hence the reason why the test failed. Okay. So we say, yeah, okay. So our assumption is still right. There's just some exceptions to our assumption. An exception is, as long as none of the values are 0, then our assumptions should still be true. And I say, okay, so let's code that. Okay, so we say, let's generate some ints, And oh, by the way, the generator that we create for generating integer values, let's filter that. Gen.filter, pass in a function that says x cannot be 0. Okay. So we just added a filter. Okay. Now what? Well, we have our generator. Our generator is going to guarantee that any values that are generated will not have 0 in it, based on this exception to our assumption that when you multiply two numbers, the result, or should I say the product of that multiplication of two numbers, will always be greater than the sum of those two numbers, hence addition. Multiplication will always be greater than addition when it comes to the product versus the sum. Okay, let's go ahead and run that. I could click run all down here, or I could just do Control RT in Visual Studio. And my assumption has to be right, given that exception that I already hard-coded. And well, why didn't my Control RT work? And do I need to hit run all over here? And well, for whatever reason, Control RT didn't work. But when I hit run all link over here in my Test Explorer, it gets updated with a -2 and a 1. -2 and a 1. So what does that mean? Well, -2 times 1 is -2, which means that -2 is greater than -2 plus 1, which would be -1. -2 is not greater than -1. -2 is less than -1. Okay. Okay. So here's another exception to this assumption that multiplying two numbers, the result will always be greater than adding two numbers. Okay. So remember, property-based testing, it challenges your assumptions. It's a tool that enhances the way that we reason about our code. Okay. What I meant to say was that if I go up here, let me update the test name to be the absolute value. My phone's ringing. I can't talk to you, Marzell. I'm in the middle of practicing, homie. So what I meant to say was the absolute value of x times y is always greater than the absolute value of x plus y. That's what I meant to say. Okay. So I need to not only update the name of my test, but I need to update the actual logic. So this prop that for all, in which we pipe in this expression of a times b is greater than a plus b. Well, I meant to say was the absolute value of a times b is greater than the absolute value of a plus b. That's what I meant to say, you know? Okay. So what happens when we run that? All right. We're scrutinizing our code. We're enhancing the way that we reason about our code. And well, okay. Well, it says Willis, like, yeah, I found another exception. The exception is that if I use this, I'm sorry, I didn't mean to say if I use this, I've auto-generated an edge case for you. I found an edge case that when you plug in the numbers or the values, -2 and -2, well, that kind of falsifies your assumption. All right. What does that mean? Well, -2 times -2 is 4. And -2 plus -2 is, well, I thought it was -4. Am I doing this right? No, hold up. I'm not that good in arithmetic. -2 times -2 is, I thought when you do negative times a negative, that's equals a positive, right? Oh, yeah. So you get 4 and 4. Well, 4 is not greater than 4. No, 4 is equal to 4, right? So in the case of -2 and -2, which is 4, it's not greater than 4, which means that this test is false because it's equal to 4. This assumption has been falsified again. Okay. All right. All right, you got me. All right. Well, I'll just add another exception, okay? My exception is that we cannot have 0 as any of the values, and we cannot have -2 and -2. Okay. Okay. So how will we code that? Well, I guess we can go down here and we can say, hopefully, gen.filter. Okay. And we have a function, and we say that we're going to have trickling in this lambda x y as a tuple, and well, I wonder if I could say something like this, that x y cannot equal -2. Come here. -2, -2. All right. That's what we want, right? We just add another exception, right, via a filter. So not only do we have an exception of cannot be 0, any of the values, but we add an exception that our tuple cannot be -2, -2, right? Because when you do multiplication and you ask if it's greater than the addition part, well, it's not greater, it's equal. All right, well, let's run that, okay? And let's see what happens. Oh, gee willikers. You know what happened is it says, I found another exception. This whole assumption, I'm finding exceptions. So my exception is that, well, -2 and -1. Well, -2 times -1 is 2, and -2 plus -1 is -3. So how does that work? Did I do that right? -2 times -1 is 2, I thought, and -2 plus -1 is -3, I thought. So remember, this is the absolute value, right? So it's really 2 greater than 3, since we're using absolute value. And well, 2 is not greater than 3. So we have another exception. Well, we're challenging our assumption. We're reasoning about our code. We're scrutinizing our code. Property-based testing, scrutinizing your code. So we need to add another exception. Okay, well, all right, well, we could do something like maybe this. We could say, okay. So we'll add another filter, and we say that a value cannot be 1. Okay. -1. A value cannot be -1. Okay. So we do that. So we have a filter for our exceptions of a value cannot, none of the values can be 0, none of the values can be -1, and none of the pairs can equal -2, -2. Besides that, multiplying A times B will always, or the absolute value of multiplying A times B will always be greater than the absolute value of A plus B, okay? So if I run that, then surely it should be green. Surely it should. And what happens? It's still freaking failing. Why is it failing? It says 1 and 1. Oh, okay. Well, I don't really have to do the math to do that. Fine then. All right. Well, we'll do 1. We'll do 1. All right. How about that? Okay. So we had another filter, aka exception, for none of the values can be 1, right? Because 1 times 1 is 1, and 1 plus 1 is 2. So in that case, addition is greater than multiplication in regards to the result. Okay, so if I run that, then surely this should pass. Because, I mean, what else is there? And it passes. Finally, it passes. Okay. Now, we need to take into consideration what our original assumption was. Our original assumption was that the value or the product of x times y is always greater than the product of x plus, or I'm sorry, the sum of x plus y. Let me start over. The product of x times y would always be greater than the sum of x plus y. And we learned that that wasn't the case. We learned that there were exceptions to the rule. We learned that, oh, you know what? We didn't mean to say the product is always greater than the sum. What we meant to say was the absolute value of the product is greater than the absolute value of the sum. But then we also had to specify some more exceptions to our assumption. We had to specify that, oh yeah, by the way, for the absolute value of the product of x and y being greater than the absolute value of the sum of x and y, well, neither x nor y can be 0. Neither x nor y can be -1. Neither x nor y can be 1. Oh, yeah, and by the way, for x and y, they can't be -2 and -2 respectively. But besides all that, that's my assumption, y'all. And my assumption works based on us scrutinizing our code via auto-generating edge cases via a property-based testing. That, my friend, is valuable. That, my friend, should be strongly considered in test automation. That, my friend, is manageable and easier to use when we do functional programming. That, my friend, relies on functions that are deterministic. That, my friend, relies on functions, not statements. If we go back to what's essential to object-oriented programming, and we go back to what's essential for functional programming, that, my friend, is one of the advantages of leveraging a functional programming language. That, my friend, gets us one step closer to removing unnecessary errors, to not receiving a phone call about something in production, to having confidence, a higher confidence that our code works by us scrutinizing it. Now, something that I didn't mention is by default, we generated 100 different values to test our assumption. Now, that's implicit. That's by default based on our property attribute. We could also change that default, and we can specify max tests equals, and we can say 1,000. Maybe it's max test equals 1,000. And we can run that. Instead of generating 100 inputs to test our assumption, we can generate 1,000 inputs to test our assumption. Uh-oh, something just happened. Gee willikers. We assumed from our default of 100 data inputs that, well, or shall I say from 100 different cases, that we were good to go. But we increased the number of values that we generated to scrutinize our function that we're testing our assumption on. We increased it from 100 to 1,000 different data inputs. And we came up with a new auto-generated edge case. This edge case is 2 and 2. Well, I know for a fact that 2 times 2 is 4. 2 plus 2 is 4, meaning that multiplication and addition, the product and the sum, well, they're equal to each other. The product is not greater than the sum when using these two operands. So that means that we found yet another exception of 2, 2. Okay. If we run that, everything is green. So if you noticed, when doing property-based testing, by default, we generate 100 different values to test our function, to test our assumption about a function, to test a property of a function, to scrutinize the code that we call our function, okay? And as we scrutinized our function, we learned of exceptions that falsify our assumption. 0, -1, 1, -2, -2 as a pair, and 2, 2 as a pair. But besides that, the absolute value of x times y will always be greater than the absolute value of x plus y. That was for 1,000. We can then do 10,000, right? We could do 10,000, and we can run that. And when we run 10,000, I have a warm, fuzzy feeling that it'll still be green, okay? And I mean, you could increase this number to whatever you want. You can make it 100,000, okay? The 100,000 is going to take a while. But again, we're leveraging property-based testing. Translated, we are auto-generating edge cases for us. Instead of brainstorming these edge cases, we're auto-generating them. We're relying on machinery to do it for us, okay? And that passed with the 100,000. So yeah, that's pretty much it. And so we look at this, and this is the code that we generated to identify the exceptions for our assumption of x times y is greater than x plus y in regards to the absolute value of them both. If we were to refactor that, our refactor code would look something like this right here that I'll just paste in. Do I do it right here? Where do I do it at? Oh yeah, we had Something's not right. Do that right there. And I know what I want to do. So this right here is refactored into this right here. Okay. And that probably looks less legible. However, if we could always separate this because these are arbitrary functions, right? We could always separate this into a separate module. And so, for example, we could theoretically create another file called, I don't know, whatever you want to call it. Utility is a poor name, but whatever. And we could throw that in there. And we would open fs check like that. And directly, I should be able to do alt up, and say open utility like that. And that is our test, okay? If you see how we refactored it, we basically took our exceptions and we made it explicit here, and we ran it through a function called filter. And the same thing here, we took other exceptions, like these exceptions were for any value, whether it's -1, 0, or 1 that got generated. These exceptions over here are tuples, -2, -2, and 2, 2. And so we basically have a refactored version of the code in which we're no longer, how do I say this? We're basically creating reusable functions that do not have hard-coded values in them. Instead, we refactored those functions, which are right here, to not rely on hard-coded values. Instead, they just receive a list of values that we call exceptions, right? Same thing with this filter right here. And these are the list of exceptions right here and also right here. In fact, well, no, that's good. And that's it. So this is me preparing for my talk at the South Florida Test Automation Meetup. And I think this is probably the best rehearsal I just did. And this was volume 4. So that's it. I'm out. Adios. Te veo a ratito. Peace.